Alright, in this video we're going to go over how to solve equations that are radical in form. So the definition of a radical equation is an equation with a radical containing a variable. So anytime we have a square root, a cubed root, where there's a variable inside of that, that's the definition of a radical equation. Now something to watch out for with radical equations is we could have the presence of extraneous solutions. And these are solutions that make sense algebraically but do not work out practically. So that means we can work it out and we can find solutions, but then when we plug them back in, they won't work. That doesn't mean we made any mistakes. It just means that although they worked algebraically, they don't work in context of the problem because of the radicals. So, three-step process on solving radical equation, and that's to isolate the radical. First step is to isolate the radical by itself, no matter what equation you're doing. And then step 2 is raise both sides to the corresponding power. So if we're dealing with a square root, we'll raise it to the second power. If we're dealing with a cubed root, we'll raise it to the third power. And then we'll finish solving using an appropriate method. And lastly, we're going to always want to check our work because of the presence of possible extraneous solutions with this type of equation. So in this example here, step 1, isolate the radical. We can see that we have a cubed root of 2x minus 4 minus 8 equals negative 6. On this side of the equal sign, the cubed root is not by itself. We have this minus 8. So to isolate the radical, we're going to add the 8 over, and we get the cubed root of 2x minus 4 is equal to the quantity 2. Now to get rid of the cube, we're going to raise both sides to the corresponding power. So to get rid of the cubed root, we're going to cube both sides. The cubed root and the cube are going to cancel on the left, leaving us with 2x minus 4. And on the right, 2 cubed is 8. Now this is a regular equation, so we just add the 4 to get 12, divide by 2, and we get x is 6. Now plugging this in to check our work. Cubed root, 2 times 6 minus 4, minus 8 is equal to negative 6. 2 times 6 is 12. 12 minus 4 is 8. So we get the cubed root of 8, take away 8 is equal to negative 6. The cubed root of 8 is 2. 2 minus 8 is equal to negative 6. That checks. Therefore, this answer is a solution to this equation. Now, in the second example here, the square root of 5x plus 3 equals negative 2. We can see that on the side where the square root is, there's nothing on the outside of the square root. So we can skip step 1, isolate the radical. We can go straight to raising both sides to a corresponding power. So to get rid of a square root, we're going to square both sides. So we get 5x plus 3 is equal to negative 2 squared is a positive 4. If you type this in the calculator, you cannot forget about putting the negative 2 in parentheses. Otherwise, the calculator will tell you it's negative 4. Now, in solving this, we're going to minus the 3, giving us 5x is 1. Dividing by 5 gives us that the answer is 1/5. Now, when we go to plug it in, we have the square root of 5 times 1/5 plus 3 is equal to negative 2. That gives us the square root of 4 is negative 2. The square root of 4 is 2. 2 does not equal negative 2. Therefore, x equals 1/5 is not a solution. This is called an extraneous solution. Although it worked out algebraically, it does not work practically when we plug it back in. So, since this problem's only solution ended up getting removed from the solution set, we say that this problem has no solution. And then now we're just going to go over a few extra examples, 4 extra examples, where they get progressively more difficult. So in this one here, the radical is already isolated, so we're going to go straight to squaring both sides. We're going to get 15 minus 2x is equal to x squared. We're going to move everything to one side because we're dealing with a quadratic. And we get x squared plus 2x minus 15 is equal to 0. The factors of 15 that make 2 are 5 and negative 3. And then when we set both of these equal to 0, we get x is equal to negative 5 and x is equal to positive 3. And then we would check our work. Square root of 15 minus 2 times negative 5 is equal to negative 5. That gives us the square root of 25 is equal to negative 5. 5 equals negative 5. That's a false statement. Therefore, negative 5 is an extraneous solution. 15 minus 2 times 3 square rooted equals 3. That gives us the square root of 9 is 3, which means 3 is 3. That checks. So x equals 3 is indeed a solution to this equation. Now in this next one, we're going to get the radical by itself, we're going to minus the 2 over. So we're going to get the square root of 12 minus 2x is equal to the quantity x minus 2. Now when we square this, we have to square the right-hand side, and to square the right-hand side, this is a binomial. So on the left-hand side, these are going to cancel, leaving us with 12 minus 2x. On the right-hand side, to square x minus 2, we're going to have to write it out twice, and then use FOIL. So we get 12 minus 2x is equal to x squared minus 2x plus 4. Moving everything to one side gives us x squared minus 2x minus 8. Factors of 8 that equal 2 are negative 4 and positive 2. Setting both of those equal to 0 gives us x could equal 4, or x could equal negative 2. And then when we go to check our work, 2 plus the square root of 12 plus 2 times 4, 12 minus 2 times 4, there should be a minus sign here, is equal to 4. So that's 2 plus the square root of 4 is equal to 4. That's 2 plus 2 equals 4. So this one checks. And then we plug in the negative 2. 12 minus 2 times negative 2 equals negative 2. This is 2 plus the square root of 16 is equal to negative 2. That's 2 plus 4 equals negative 2, and that's false. So this one gets removed from the solution set. And then the last two examples that get progressively more difficult. I'm going to go over the one on the right first just because it's the easier of the two. This one is an example where we have a square root with a square root inside of it. But if we look at this problem, we have the square root, there's nothing on the outside of it, so it's already by itself. So we're going to go ahead and square both sides. And in doing that, this square and square root are going to cancel, leaving us with 10 plus 3 radical x. Over here, the square and square root are going to cancel, leaving us with just x. And then now, we still got another radical. So we've got to go back to isolating radical again. So we're going to minus the 10 over. We get 3 radical x is equal to x minus 10. Now we could technically divide by 3, but that's going to give us fractions. So rather than doing that, we're going to just go ahead and square both sides. 3 squared is 9. Square root of x squared is x. Because the square and the square are going to cancel. To square x minus 10, we have to write it out twice. And we're going to use FOIL. So we get x squared. So we get negative 10x, another negative 10x to give us negative 20x, and positive 100. Moving everything to one side gives us x squared minus 29x plus 100. Factors of 100 that make 29 are negative 25 and negative 4. Setting both of those equal to 0 gives us x could equal 25, or x could equal 4. Plugging these in, square root of 10 plus 3 square root of 25 equals the square root of 25. That is the square root of 10 plus 3 times 5 equals the square root of 25. That's the square root of 25 equals the square root of 25. So this one checks. Then we're going to plug in the 4. 10 plus 3 square root of 4 equals the square root of 4. This is going to give us 10 plus 3 times 2 equals the square root of 4. That's the square root of 16 equals the square root of 4, which is not true. So this is an extraneous solution and therefore it gets marked out. And in this last example here, we have two radicals appearing on the same side. So we just pick one to get by itself. So we're going to add this one over. And we get the square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. And then as we've done earlier, we're going to square both sides. These are going to cancel on the left, square and the square root, leaving us with 2x plus 3 equals, and then we're going to have to take 1 plus the square root of x plus 1, and we're going to have to write it out twice and then use FOIL. So we have 1 times 1 is 1, 1 times radical x plus 1 is radical x plus 1, radical x plus 1 times 1 is radical x plus 1, and radical x plus 1 times itself is just the quantity x plus 1. Square root of x plus 1 times the square root of x plus 1 makes the square root of x plus 1 squared, leaving you with just the quantity x plus 1. So we get 2x plus 3 is equal to x, 1 plus 1 makes 2. This is 1 radical x plus 1 plus 1 radical x plus 1, giving us a total of 2 radical x plus 1. And then now we still have a radical present, so we're going to fall back to that appropriate method, which means we have to get that radical by itself. So we're going to minus this x over. We're going to minus 2 over. And we get x plus 1 is equal to 2 radical x plus 1. And just like over here, if we're not going to divide the 3 over because it's a Lewis fraction, we're not going to divide this 2 over because it's a Lewis fraction. So we're going to go ahead and square both sides. That means we're going to do x plus 1 times x plus 1, which is x squared. 1x and 1x makes a total of 2x. 1 times 1 is 1. When you square this side, you got to square both. Which means 4 times the square root of x plus 1 squared is just the quantity x plus 1. So the right hand side is going to be 2x plus 4. And then this is quadratic, so we're going to move everything to one side, so we're going to minus the 4x over. And then minus the 4 over. So x squared minus 2x minus 3 equals 0. Factor the 3 and make negative 2 or negative 3 and positive 1. Setting these both equal to 0 gives us x is 3 or x is negative 1. And then plugging those both back in. Square root of 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1. That's the square root of 9 minus the square root of 4, which is 3 minus 2. 3 minus 2 does equal 1, so 3 works, it's a solution. 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. That's the square root of 1 minus the square root of 0, which is 1 minus 0. 1 minus 0 does in fact equal 1. So in this case, they both are solutions. So the answer to this one is x equals 3 and x equals negative 1. Those are both solutions to this equation. Alright, and then that's going to finish up this video.